Hi there, and welcome back to another Papetti Math YouTube video tutorial, where I'm going to be teaching you, yes you, Algebra 1. And in this video, we're going to look at more absolute value graph transformations. So in Lesson 1, you learned what makes an absolute value graph shift up, down, left, or right. You also explored what makes an absolute value graph wider or narrower. In this lesson, you will combine multiple transformations to gain a better understanding of shifts and stretches. So in exercise number 1 in lesson 2, it says consider the absolute value function g of x is equal to the absolute value of x plus 3 minus 2. What two transformations have been done to this function? So let's first take a look at what's being done inside that absolute value. And you might notice that you have x plus 3. So we're adding inside. And we should remember from lesson 1 that when we add inside, we shift the function to the left. So this has been shifted 3 units left. But that's not all that's being done to this function, because in addition to being shifted 3 units left, we're also subtracting 2 outside of the absolute value. And we learned in lesson 1 that when you subtract on the outside of an absolute value, it's shifted 2 units down. So this function has been shifted 3 units left and shifted 2 units down. So knowing that much, we know how to graph this function without even setting up a table, because we know where our vertex is going to be. It's going to be 3 units to the left of 0, 0 and 2 units down. So our vertex is going to occur at the point -3, -2. Once we know that, and we see that no number is being multiplied by it, we know the slope of this is just going to be up 1 over 1, up 1 over 1. Now let's take a look at where we want to graph this, because it says to graph the function over the interval from -6 to 4. Notice how -6 is not included in the interval because there's no equal sign under the inequality. But 4 is included in the interval because there is an equal sign under that inequality. So let's find where -6 is. -6 occurs right here. So we're going to go up to this point on our graph, but we're going to not include it. So we do that by using an open circle. So we're going to go up 1 over 1 because we know that's our slope, up 1 over 1 until we get to -6, which is right here, and our point is going to be there. And again, since it's not equal to, we're going to use an open circle to denote that. Now I can erase my little mark on the graph right there. There we go. Now we're going to go up 1 to the right 1, going in the opposite direction until we get to the x value of 4. So here we are at 1, 2, 3, 4. And I'm going to put a closed circle at 4 because it says it's equal to 4 in the interval. Now that I have my open circle on the left constraint of my interval and my closed circle on the right side of my interval, now I could connect these points with a nice solid line from the open circle to the vertex, and then from the vertex to the closed circle. So there we have the graph of g of x over the interval from -6 is less than x is less than or equal to 4. And again, that is the absolute value graph that is shifted 3 units left and 2 units down from the parent function. If this video was helpful in order to see how an absolute value is shifted when it undergoes 2 transformations and how to graph it over a specific interval, give this video a thumbs up. And you're now ready for exercise number 2. Thank you for watching.